In this video, we'll learn how to make inferences about two means for independent sample. This is chapter 9.2 from our textbook Elementary Statistics by Mario Triola. And in this part, we'll learn how to conduct the hypothesis test of a claim about two independent population means. We'll use Ch9-2 calculator and the StatCrunch. The notations will be the same what we used for one population, mu population mean, x bar sample mean, sigma population standard deviation, s sample standard deviation, n is the size of the sample. And we'll use sub 1 for the first population and sub 2 for the second population. The requirements for two means in independent samples are that the values of the standard deviations from both populations are unknown, and we don't assume that they're equal. The two samples are independent, and both samples are simple random samples. And also, either or both of these conditions are satisfied. The two sample sizes are larger than 30, or both samples come from the population, have a normal distribution. Now let's look at the following example. Listed below are the student course evaluation scores for courses taught by female professors and male professors. We'll need to use 0.05 significant level to test the claim that the two samples are from populations with the same mean, and then answer the question, does there appear to be a difference in evaluation scores of courses taught by female professors and male professors? Let's check the requirements first. The first requirement is that the values of the two populations' standard deviations are not known, and we're not making assumptions that they're equal. The two samples are independent, yes, because the female professors and male professors are not matched or paired in any way. Number 3, the samples are simple random samples, yes. And 4, both samples have to be greater than 30 or from the population that has a normal distribution. When we built a normal quartile plot of the two samples, it shows that the samples are from a population that has a distribution close to normal. So all the requirements are satisfied. Our claim is that the two samples are from populations with the same mean. Let's write it in symbolic form. Mu1 is equal to mu2. The opposite of the claim would be that mu1 is not equal to mu2. Step 3. Identify the null hypothesis and alternative hypothesis. The null hypothesis, the one that has the equal sign. Out of these two statements, our original statement has equality. Mu1 is equal to mu2. Alternative hypothesis would be the opposite statement. Mu1 is not equal to mu2. So notice the sign of the alternative hypothesis. Step 4. Identify significance level. Significance level alpha is given as 0.05. Step 5. Identify the test statistic. The test statistic is T because we're testing the claim about population means. So we are using the T distribution. Let's do it on the graphing calculator first. We can test the claim about population mean by going to Stat, Test, two sample t-test. Now we have two choices. We can either use data or use stats. Because we have data given for the two samples, we need to input the data. So go back to Stat, Edit, click Edit again, and enter the data from our sample. Sample 1, female population, would be list 1, and male population would be list 2. Enter the values in your graphing calculator, and when you're ready, Go back to Stat, then Test, two-sample t-test, enter. Now we can use the data from list 1 and list 2, leave the frequency the same. 1. Mu1 is not equal to mu2 from alternative hypothesis. So we pick not equal to sign, pooled no, go to calculate, click enter, and write down the values of t-statistic and the p-value. T-statistic is negative 0.66 rounded to 2 decimals, and p-value is 0.517, which is much greater than our significance level of 0.05. Therefore, we make conclusion that we failed to reject null hypothesis. Because we failed to reject null hypothesis, we say that there is not sufficient evidence to warrant rejection of the claim that female professors and male professors have the same mean course evaluation score. If you forgot how to rewrite conclusion in non-technical terms, feel free to pick up in the table of wording the final conclusion. Since our original claim includes equality and we failed to reject the null hypothesis, here would be our conclusion. There is not sufficient evidence to warrant rejection of the claim. Restate the claim. Now let's do the same calculations using StatCrunch. Log into your StatCrunch and enter the values of the first population in var1. The second population would be in var2. Once you enter the values, then go to Stat, T-Stats, because we're using t-distribution, to sample, with data, select column var1 for first population, select column var2 for the second population, go to hypothesis test, click on hypothesis test. We're not doing the confidence interval yet. When we do the confidence interval, then you will click on the confidence interval. Make sure that you enter the right alternative hypothesis, which is not equal to in this case, and go to compute. As you can see, we get the same t-statistic negative 0.66 and the same p-value of 0.517. I wrote down a calculator key and a StatCrunch key. Whichever method you use, feel free to use any. As you could see, we get the same result, that t-statistic is negative 0.66 and the p-value is 0.517. Therefore, we make the same conclusion, and we fail to reject null hypothesis. Now let's use the critical value method to test our claim. Let's draw a distribution. Remember, t-distribution is similar to the z-distribution or the normal distribution, depending on the sample size. Our sample size, the first one was 12 values, and the second sample had 15 values. For the degrees of freedom, we're going to use the smaller out of the two, which is 12. 12 minus 1 would be 11. So that would be our degrees of freedom. Now let's decide where is our critical values located. Our alpha for the two-tailed test, because alternative hypothesis had not equal sign. So our test is two-tailed test. Our alpha was 0.05. Therefore, in both tails, we will have 0.025. 0.025. We can use the calculator or table A3. let me show you how to use the calculator. In the calculator, we will need to identify the area to the left of our critical value. The area to the left of this critical value would be 1 minus 0.025, which is 0.975, and degrees of freedom is 11. So on your calculator, you go to second vars inv t, click enter, and you're gonna enter the area to the left of your test statistic, degrees of freedom 11, click enter again. Our t statistic or our critical value t is 2.20. So let's write it down, 2.20, rounded to 2 decimals. If we use the table A3, it might be slightly different here. But in any case, remember what was our t statistic? Our t statistic was negative 0.66. It's a two-tailed test, so it's negative 0.66 here and positive 0.66 on the other side. And the mean is 0. Notice where the t value is located. It's located in non-critical region. Therefore, we do the same conclusion that we made when we used the p-value method, that we failed to reject null hypothesis, and there is not sufficient evidence to warrant rejection of the claim that female professors and male professors have the same mean course evaluation score. Now let's go back to the question and make sure we answered it. Does there appear to be a difference in evaluation scores of courses taught by female professors and male professors? No, there does not appear to be a big difference in evaluation scores of courses taught by female and male professors.